Hello everybody and welcome to our first lesson in our unit on area and volume. Today we will talk about area and perimeter of two-dimensional objects, and our objective for today is we will be able to use formulas for area, perimeter and circumference of two-dimensional objects to solve real-world problems. Let's first review those main concepts one more time. Area is the space covered in two dimensions, and we're using square units for that. I want you to think of cover, think of cover, covering something maybe with paint or carpeting or tiles, anything that covers a two-dimensional space. In this rectangle here, that would be covering the entire inside. Perimeter is the total length of all sides of a two-dimensional figure. And here I want you to think of, for example, the distance around an object or the rim of something. If we had a rectangle like this again, this time we would be talking about the distance around, and that is around all the sides of that object. Volume is the space contained in the interior of a solid object. Now we're talking about a 3D object, and that's why we're using cubic units. I want you to think of filling something up. I want you to think of filling something up, like, for example, the liquid in a cup or something like that. For volume, we use cubic units. So, for example, cubic centimeters, cubic feet, and we can show that by using the exponent 3 for cubic, or we can just write it out like cubic inches, for example. Area, we use square units, so that would be, for example, centimeters squared, feet squared, or square inches. Throughout this unit, we will be using the formula sheet that has a lot of formulas for calculating two-dimensional and three-dimensional objects. Let's start with these two. To the left here, we have a pyramid. A pyramid has one base, and then the sides all converge together at the top. A prism, on the other hand, always has two bases. So the base is not only necessarily the base is not only necessarily the surface at the bottom of the object, but it is also the surface which is parallel and on the other side of the object. So prism has two bases. The bases of pyramids and prisms can be different things. The most common ones are rectangles, squares, and triangles. And therefore we have the formulas for the areas of those shapes here as well. And mind you, the prism is shown as a triangular prism here, but we also have rectangular prisms as well. To calculate the volume of a pyramid or a prism, we need to know which shape is the base of that object. So that's why in the volume formula we have here the capital B, and the capital B stands for the area of the base. And so we need to know what type of base is it and use the respective area formula. In this case, it would be the area of a rectangle, or it could also be a square. And if we're looking over at our prism, that also needs the area of the base for the volume formula. And in this case, it would be the area of a triangle. And similarly, to find something that's called lateral area or surface area of a three-dimensional object, and we will discuss that in a later lesson, we need the perimeter of that object, and that will then again need for us to use the formula for the perimeter, which we have here on the formula sheet as well. So let's look at our first couple of examples. A rectangular pyramid whose base measures 5 feet by 3 feet is shown. Rectangular indicates to us the shape of the base, which we need to keep in mind for the rest of the problem. Find the area of the base of the pyramid. The base is the shape of a rectangle, as we have said, and we are told that the base measures 5 feet by 3 feet. Now, looking at our formula for area of a rectangle, the way we calculate is by using the length times the width. So area is equal to length times width. The length of our rectangle is 5. The width is 3. 5 times 3 is 15. Now we do need to also indicate the units. We have an area that's a two-dimensional. We have an area that's two-dimensional. That means we use square units. Feet in this example, and 15 square feet, therefore, is our answer. In our second part, find the perimeter of the base of the pyramid. And our base is still a rectangle, and now we're finding the perimeter. Remember, it is 5 feet long and 3 feet wide. And our formula for the perimeter says the perimeter is 2 times the length plus 2 times the width. So let's plug in our numbers. 2 times 5 plus 2 times 3, and that is 10 plus 6, 16. And since we're only adding the lengths, we're not multiplying anything, the unit is still straight feet, 16 feet. Now let's move on to our prism. A triangular prism is shown. Find the area of the base of the prism. The base of our prism is a triangle, and so we're going to use the formula for the area of a triangle, and that is A is equal to 1/2 B times H. So let's have a look at our prism over here. And as you can see, our triangles are actually not on the top and on the bottom. They're on the sides. That doesn't matter. Those are still the shapes that shape our prism. And even if it's flipped over to the side, if it's a triangular prism, we call the triangles the bases. So these are the measurements we're going to use for our formula. We have the base, and that's the lowercase b. The base of our triangle is 12 centimeters. And remember, the height has to be perpendicular to the base, and we have a right angle here, so 16 is our height. Then it's 1/2 times 12 times 16. Get rid of the 1/2. Do 6 times 16, and that is 96. Now area again is a two-dimensional item. We have centimeters, so our area is centimeters squared. And in the second part of this example, we're supposed to find the perimeter of the base of the prism. The perimeter of a triangle, there is no specific formula for that because all you really do is add three sides together. Sometimes all three have different measurements, sometimes some have the same. So we just need to know the measurement of each side and then add all three together. And then add all three together. So I'm going to start off by drawing our triangle and see which sides we were given. With our right angle here, we were given the base, which is 12 centimeters, and one side, which is 16. We don't know the third side. And as it happens, as you look at your right triangle here, the third side missing is C, our hypotenuse. So we can use our Pythagorean theorem to find C squared and also C. C squared C squared is equal to A squared plus B squared. That means C squared is equal to 12 squared plus 16 squared. That means C squared is equal to 144 plus 256, which is 400. And then taking the square root of both sides, we find out that C is equal to 20. And now we can calculate our perimeter. The perimeter of our triangle is 12 plus 16 plus 20, and that makes 48. Perimeter is one-dimensional. We keep the unit of the three sides, which is centimeters, and here we are. Alright, so much for this, and now go ahead and watch the second part of this tutorial.